In this video, I'm going to go through page 1 of the study guide review. So let's dive right into problem number 1. Problem number 1 asks us to determine whether the function graph below is invertible, and you need to explain it. So remember, to be invertible, a graph needs to pass the horizontal line test. So I just drew a horizontal line, and unfortunately this graph crosses that horizontal line twice. So is the function invertible? No. And the reason is it fails the horizontal line test. Because it failed the horizontal line test, it is not invertible. All right, problem number 2. Which function is not invertible? And we have an option here. So you have x, x to the fourth, x to the fifth, and x to the third. Now, one thing to pay attention to is basically one of these things is not like the others. G of x, which is x to the fourth, is the only function there that has an even degree. That's the one that is not invertible. Explain 2 reasons why. First reason is it is an even degree power function. And even degree power functions are not invertible. The second reason is you could actually graph it. And if graphed, the function would fail the horizontal line test. And visually what that would look like, x to the fourth is a concave up graph that looks something like this, and the horizontal line test would of course fail in 2 points. All right, so x to the fourth is the one that is not an invertible function. All right, problem number 3. How can you determine without graphing whether a function is invertible? Explain. So, without graphing, there are 2 things you can look for. If you have an even degree power function, and I'm going to put a couple of these in parentheses so you know what I'm talking about. An even degree power function would be things like x squared, x to the fourth, x to the sixth, and it keeps on going. All of the powers are even numbers. So if you have an even degree power function, it is not invertible. I think I'm spelling invertible wrong, so let me try that again. No, I think I was spelling it right. That's okay. It's not invertible. If you have an odd degree power function, and that would be x cubed, x to the fifth, x to the seventh, any odd degree power function, it is invertible. Now, what you want to be careful about with the odd degree power functions is it's not all odd degree functions, it's all odd degree power functions. So x cubed is a power function. X cubed plus x squared is not a power function. So just be aware of that. So it has to be the power functions that you can tell if they're invertible or not just by looking at the equation. All right, problem number 4. The function h of x is equal to x to the fourth is invertible if its domain is restricted to x is greater than 0. Write the equation for h inverse of x. So the inverse of a x to the fourth is going to be the fourth root of x. Every power function, every power has an inverse root that is its inverse operation. All right. Write the domain and range for the functions h of x. So h of x is the original function here. However, it's been restricted. The domain has been restricted. So speaking of domain restrictions, we're going to do x is greater than or equal to 0. Range in this case is also going to be greater than or equal to 0. Now, whatever your domain for the original function is, that's going to be your range for the inverse. Whatever your range for the original function is going to be your domain. Now, these look the exact same, but this domain right here is what becomes that range, and this range becomes that domain. All right, so that's how those inverse functions work, because you're swapping the x's and y's. Sketch the graphs of h of x and h inverse of x on the coordinate plane below. Label the graph of each function. So h of x being x to the fourth, but remember we're only going to restrict our domain to being positive x's. Is going to look something like this, and that is h of x. The inverse function is going to start in the exact place, the 0, 0 position, and it will curve to the right. So this is h inverse of x. So that's the half of the x to the fourth function, and this is the fourth root of x function. Okay. The function k, this is problem number 5 already, so k of x is equal to x cubed is invertible. Sketch the graph of k of x and the inverse of k of x on the coordinate plane below. Label each function. So x cubed looks something like that. So this is k of x. I don't know why I keep putting that parentheses in the wrong place. There we go, k of x. If we invert it, we're still going to have 0, 0 here, but this part that's increasing very quickly on the y-axis is going to increase very quickly on the x-axis, and also true to the left. And this is going to be inverse k function. I'm actually going to do problem number 7 next, because this function actually relates to this one. It says to write the domain and range of f of x. Wait a minute. Yep, that's kind of weird, but so f of x here is the x cubed function that we just drew here in orange. So the domain is going to be everything, all possible x values work. Range, all possible y values are there. So both domain and range for x cubed are negative infinity to infinity. Problem number 6. The function g of x is equal to x to the 6th is invertible if its domain is restricted. All right, so we're going to sketch x to the 6th, but only the positive part of it. It's going to look something like this. This is g of x, and we are going to invert it. So start at 0, 0 here, and it quickly grows on x, but it's a very slow growth on y. We labeled them, we graphed them, okay, great. And now we're going to consider this function, write the domain and range. Now, one thing to be careful about for this f of x problem here, for problem number 8, there is nothing here that says the domain is restricted. So just be aware of that. So for x to the 6th, the normal domain is all possible values of x, so negative infinity to infinity. The range for x to the 6th, the lowest value that we can get for y is 0, and everything else is positive. All right, so that whole first page was a lot about functions, invertibility, and your power functions and their inverses. If you have any questions or concerns, let me know. I will have separate videos for pages 2, 3, and 4.